Okay, we're going to move on today to solving inequalities. And an inequality is something like the one that we've got written down here, where we can see that 2 is smaller than 6, or 6 is smaller than 2. So the inequality that's in the middle here is a true inequality. But we're going to have a look at what happens when we do certain things to both sides of an inequality. Does an inequality behave in the same way as an equation behaves, where if you do the same thing to both sides, the equation remains true? Okay, so let's start with this one over here on the right. So we're going to go in this direction. Let's just get a pen. So we're going to go this way. And the inequality, the instructions on the spider says add -2 to both sides. Well, that's just subtracting 2 from both sides. So if I subtract 2 from the left, I get 0. If I subtract 2 from the right, I get 4. Is that inequality still true? Yes, it is. 4 is bigger than 0. 0 is smaller than 4. Okay, subtract -2 from both sides. Well, subtracting -2, if you like, that's minus -2. That's the same as adding 2 to both sides. Well, 2 plus 2 on the left, we can get 4. And on the right, we get 6 plus 2, which is 8. Is the inequality still true? Yes, it is. Okay, let's have a go at dividing both sides by 2. So that's this one down here. 2 divided by 2 is 1. 6 divided by 2 is 3. The inequality is still true. Okay, going this way, subtracting 2 from both sides. 2 take away 2 is 0. 6 take away 2 is 4. It's actually the same as that one top right, isn't it? Still a true inequality. What about going this way? Adding 2 to both sides. So that becomes 4 is smaller than 8, which is the same as subtracting -2. So it's the same as this one over here, bottom right. Still a true inequality. Okay, let's have a look at the top left one here. Multiply both sides by 2. 2 times 2 is 4. 6 times 2 is 12. The inequality is still true, isn't it? 4 is smaller than 12. I've deliberately left these last two until last. Let's have a look at what happens when we multiply both sides of our inequality by -2. So this one becomes -4. So 2 multiplied by -2, 6 multiplied by -2 is -12. And let's write down the inequality, and let's just think which of those two numbers is actually bigger. Well, if you think of a number line, okay, there's 0, there's -4, -12 is down here somewhere. -12 is actually smaller, or -4 is the bigger one. That inequality is no longer true. But if I wanted to make it true, all I would need to do is take the inequality, rub out the inequality sign in the middle there, and swap it round so it's actually pointing in the other direction. So I'll just do it in blue. So it's actually true if I write it this way round. Okay, so the inequality becomes false when I multiply both sides by a negative number, -2. In fact, it's true for all negative numbers. If you've got an inequality which is true, multiply both sides by a negative number, it becomes false. But to make it true again, just change the direction of the inequality sign. Now, the other time that that is also true is this one down here. If we divide both sides by -2, well, the left-hand side, 2 divided by -2 is -1. 6 divided by -2 is -3. Now, again, that inequality, written that way round, is false because actually -1 is bigger than -3. And to make it true, all I need to do is get rid of the inequality, swap it round so it points in the opposite direction. Again, let's do it in blue. And it becomes now a true inequality. So this one up here, top right, is also true. So the rule is this: for an inequality, if you multiply or divide both sides by a negative number, the inequality sign has to change direction. So if it points to the right, you change it so it points to the left. Now, that is very important when it comes to solving inequalities. So what we're going to do now is we're going to look at solving a few inequalities. Okay, so solving inequalities is just the same as solving equations, except for when you multiply or divide by a negative number. So if you've got a simple equation like 2x is bigger than 6, and you wanted to solve that, you would just divide both sides by 2. The left-hand side becomes 6. The right-hand side is 6 divided by 2, which is 3. The inequality points in the same direction as before. If you had an equation like, or an inequality rather, like x plus 6 is smaller than 10, and you wanted to solve that, all you've got to do is take away 6 from both sides. The left-hand side becomes 6, the right-hand side becomes 4. The inequality doesn't change direction. The only time that the inequality changes direction is when you have to multiply or divide by a negative number. So let's have a look at number 1 here. So we have got minus 2x is greater than 4. Now the quickest way to do this is just to divide both sides by minus 2, because what I want to do is I want to make that left-hand side into just x, and the quickest way to do that is to divide both sides by minus 2. But when I do that, because I'm dividing by a negative number, the inequality sign changes direction and it points left instead of right. Now do the same on the right hand side. 4 divided by minus 2 is minus 2, and there is the solution to the inequality. Now sometimes you can get away with making life a little bit easier for yourself, so you could choose here. So let's just have a look at number 2. You have a choice with number 2. Let's just move that down out of the way. So here are your choices. Choice 1, okay, let's put that over here. Let's do it in blue. Okay, let's do it over here. So I could solve it in the same way that I've been asking you to solve equations up until now. So I could add 5x to both sides, put it in a circle as usual. So on the left-hand side, if I add 5x, I'm just going to be left with 7. Sorry, that should be an inequality. I copied that wrong. So let's just copy the inequality. Because I'm adding 5x, by the way, there's absolutely no need for me to do anything with that inequality sign. Leave it as it is. Okay, I haven't divided or multiplied by a negative number. I've added 5x to the left, and if I add 5x on the right, I get 19 plus 5x. Okay, what do I do next? Well, I'm going to leave the 5x where it is, and I'm going to subtract 19 from both sides. Notice I'm not dividing by that, I'm just subtracting 19. So subtracting 19 on the left, I get minus 12. Subtracting 19 from the right hand side, I get 5x. And I've subtracted, I haven't divided, I've just subtracted. The inequality sign stays as it is. Now I'm going to divide both sides by 5. So my right hand side becomes x. My left hand side rather is minus 12 over 5. And my inequality sign doesn't change because I have divided both sides by 5. Now to give your solution to your inequality, same as for equations, x should be on the left. So I'm going to swap the x to the left. I'm going to put minus 12 over 5 onto the right. And then, because I've swapped the left and the right, I'm going to turn the inequality sign round. So that's my solution. Okay. Alternatively, this is what I could have done. Started with 7 minus 5x is smaller than or equal to 19. So leave the minus 5x where it is and take away the 7. 7 is positive, so let's take away 7 from both sides. Do I need to swap the inequality sign? No, I don't, because I've subtracted 7 from both sides. Leave it as it is. So this is going to stay pointing in the same direction. Take away 7 from the left, and I'm left with minus 5x. Take away 7 from the right, and I am left with 12. Okay, now what am I going to do? Well, I'm going to divide by negative 5. If I divide by negative 5 on the left, I've got x. Divide by negative 5 on the right, and I've got minus 12 over 5. Remember, that comes out as negative. And here I have divided by a negative number, so I'm going to swap my inequality sign round, so it now points to the right. So notice both ways that I've done that, I've ended up with exactly the same answer. X is greater than or equal to minus 12 over 5. And if I wanted to put that on a number line, remember like you were doing last time, here we've got you could write it as x is greater than or equal to minus 2.4. That might be a bit easier for you to understand. Okay, so there's 0, there's minus 1, there's minus 2, there's minus 3. Minus 2.4 is just a bit less than minus 2, so I'm going to put it about there. And because it's greater than or equal to, remember we draw a coloured in circle, so our solution here could be any number from minus 2.4, let's just label it there as minus 2.4, any number from minus 2.4 upwards. Okay. Okay, let's have a look at another one. This one's got a bracket, but you know how to deal with brackets. Remove the bracket on the left-hand side. 3 times 2 is 6. So we've got 6 plus 3 times 3x is 9x, and that's greater than minus 5. So all I've done so far is remove the bracket. Okay, leave the 9x where it is. I'm now going to subtract 6 from both sides. So 9x stays where it is. I'm subtracting 6, no need to move the sign. Minus 5 take away 6 is minus 11. Now I'm going to divide both sides by 9. Okay, I'm dividing by a positive number, no need to change the sign. So I've got x greater than minus 11 over 9. Okay, didn't have to do anything with changing the sign there. Right, I've put number 4 in because you might be asked to solve, I call it a triple inequality if you like. Just think of it as an equation that's actually just got 3 bits to it instead of 2. You can't do this with equations, but we can do it with inequalities. So we've got 2x minus 3 smaller than or equal to 11, but greater than or equal to minus 10. And your job is to get x on its own in the middle. If I add 3, and when I write add 3, I'm going to add 3 to each part of my inequality. I'm adding 3. The inequality sign does not need to change. So 11 add 3, 14. Minus 10 add 3 is minus 7. 2x minus 3 plus 3 in the middle is just 2x. Now, to get x on its own in the middle, I'm going to divide both sides by 2. The middle then just becomes x. On the right-hand side, we get 14 divided by 2, which is 7. On the left-hand side, we get minus 7 over 2. Let's write it as minus 3.5. Because I've divided by 2, by the way, none of the symbols change. If I were then asked to draw that on a number line, you can really cheat here with number lines. This is what I tend to do. Here's minus 3. Here's minus 2. Here's minus 3.5. Zero's up here somewhere. Doesn't really matter if the numbers aren't spread out properly. And there's 7. So x is any number between minus 3.5 and 7, including minus 3.5. So a coloured in circle there, including 7. So there's a coloured in circle there. And remember, we just draw a straight line between the two. So x is any number between minus 3.5 and 7.